So hello everybody and welcome to What Do Scientists Do? It's a show where I talk to a different scientist each episode and they tell us all about their favorite science topics and what it's like to work in the world of science, technology, engineering, and math. My name is Jessica and today I'm joined by our very special guest. Could you give us your name and your pronouns, please?
Yes, I'm Dr. Kevin Leblanc, and he and him would be my pronouns.
And Dr. Leblanc or Kevin, which you prefer?
Kevin's fine.
So Kevin, what kind of scientist are you?
Good question. So I guess I would be classified as a cognitive neuroscientist, so in which the cognitive neuroscience is the study of how the brain produces thoughts and behaviors. So essentially we combine the field of neuroscience, which is the scientific study of the brain, with the field of cognitive psychology, which is the branch of psychology which explores our internal mental processes, such as learning, memory, attention, motor control, decision-making, the list goes on. So, as a cognitive neuroscientist, our main goal is trying to map out and organize how the brain supports these cognitive processes. So I guess in more simple terms, you could describe a cognitive neuroscientist as someone who studies how the brain enables the mechanisms of the mind.
Cool. So like how the brain creates the mind and your consciousness and all that stuff that's happening inside your brain all the time.
Yes, exactly. And we use the techniques of neuroscience to try to map it out and organize what's connected with what in order to kind of get these processes to emerge and to do our everyday behavior.
Cool. So what do you specifically study?
Yeah, so I specifically research how the areas of the brain responsible for perception, attention, and action kind of interact with each other to successfully guide us when we're controlling our visually guided movements on a daily basis, whether it's just picking up a coffee cup or doing a complex action such as doing a slap shot or playing the guitar, for example. So one of the main tools that I do in my research is that when I conduct research, I use 3D motion capture. So essentially we place little sensors on your hand and we have fancy cameras in the lab that will pick up on those sensors. And I get you to reach out to different sizes of objects, and the objects are placed all over the place. And by having these sensors on your hand, we can precisely measure a lot of cool things that you are not actually consciously aware about. So this could be your wrist orientation, the trajectory you're going through, the width of the opening of your hand, or even the hand speed in itself, and a lot of other fun measurements. So by gathering these data, it kind of allows us to perform all types of manipulation and see how the grasping hand, in this case, if I'm using that example, can be affected by the context of the movement, or the mere presence of other objects or other intentions. For example, if I look at the desk here, I have my coffee cup next to my computer. Does grasping towards my coffee cup, is that affected in any way by the presence of the computer versus if I was just grasping the cup on its own? So I like to see how kind of future actions can impact present actions and the whole interplay between what you're perceiving and how you plan it into a motor action. So by capturing results like this, it kind of clarifies how the brain organizes and produces goal-directed movements. So by doing what I call basic scientific research, which maybe fundamental scientific research is a more appropriate term, can lead us to the formation of new theories that we can test out, and this can essentially become applicable to treating various brain injuries, all the way to even applying it to robotics. So basic, simple research that you probably never even thought about, that you do on a daily basis that you're not even aware of, but measuring those precise kinematics of the hand can actually give us a lot of insights about how the brain programs that action. So that's kind of my main wheelhouse. I also have other interests. I'm interested in how exercise improves cognitive processes as well. And also, I'm an instructor, so I'm obviously very passionate about teaching. So I like to compare different teaching methods and how it affects different students.
Cool. So you care a lot about those things happening in our brains that we're not even aware of. Like we're not making the decision to move differently if our laptop's there versus when our laptop's not there. So is there anything specific that you've discovered? Do you have any results that were...
Yeah, so I guess what I focus my PhD on, which I just recently graduated, essentially is, so in the brain, so at the very back of your brain, you have the occipital cortex, which receives most of the visual input from the eyeballs. And from there, the information kind of separates into two distinct streams. You have what we call vision for perception, which the information goes down to the temporal lobes. And that gives you rise to your conscious perception of the world. So the fact that I can perceive this coffee cup, the fact that I can perceive your face, and whatnot. However, there's also information that goes upwards towards the parietal and the frontal lobes, and this is where all the motor processing happens and the attention stuff happens. So what I was wondering in my PhD is how does a second task in an action, so let's say you're doing two actions, one after the other, whether the second action is another action, so you have to physically interact with it, or are you just simply perceiving it, how does that affect your first action? So I guess my goal was to figure out, do we program actions in terms of kind of optimizing the motor system, so you know that you're going to do two actions in a row, so you're going to plan for the second one before the first one. However, if you're just perceiving the second one, you shouldn't be doing that. So that's kind of was my manipulation, whether you're doing a perception task with a second object or an action task. Turns out they both affect you. So whether they affect you in a similar way and a similar route in the brain is still to be discovered, but essentially it seems that we know a lot about how we grasp one single object. There's a bunch of research on that, but when it comes to planning sequential actions, which that's what we do on a daily basis, it's rare that you just pick up one object, then you're done for 5 minutes and you do another thing. It's usually a case where you're performing multiple actions at once to do one main goal. So it turns out that we don't know a lot about how we prepare those sequence of actions. We know a lot about one single action, but how do we prepare that sequence and whether perception plays a bigger role than just doing one single action when it comes to having a higher order goal where multiple objects are involved. And there's a lot of cool theories about attentions involved there as well. So yeah, that's kind of what I was interested in. I did not get clear results, but that's how science works. But definitely results that we can build off upon, and we know what to do, and we know what to do better now.
Yeah. And I mean, the brain's super complicated, right? Like, neuroscience even hasn't been around for very long,
Exactly.
has it?
No, not at all. It's a new science, an emerging science, and it's a science that collaborates with all the other science. So if you're interested in chemistry, there's a lot of chemistry involved. If you're interested in computer science, there's a place for computer science here. So that's one beautiful thing about neuroscience and psychology and cognitive neuroscience, if you're talking to me.
Yeah, it's really interesting how we know some things about the simple actions, but we don't even understand fully how we tell our brain to do multiple things at a time.
Exactly.
Which seems like such a simple thing that would be easier to understand.
Yeah, and just think about your daily actions. So let's say you put on your favorite shoes this morning. You were consciously perceiving the shoes, you selected your shoes. However, are you aware about how you reached out for your shoes? Were you specifically consciously preparing the width of your hand? No, that all happens automatically, which is quite impressive. So that's why using tools like 3D motion capture, we can kind of dig underneath the surface and see, all right, what other things that we are consciously aware of can affect the things that we're not consciously aware of. And turns out this leads to many emerging theories, which, like I already mentioned, can really help with how we treat brain injuries, and also the applications of robotics, which is another emerging field that will only get more and more popular.
Yeah, I guess if you understand better how the brain controls like our movements and our actions, you can more easily make the computer brain to control a robot's actions.
And you look at the best robots out there, they're all modeled based on neural networks, which is the stuff that we study as human neuroscientists as well. So yeah, you definitely have a valid point there.
Yeah, that's really cool. So you've done all this cool stuff with the brain. Do you have a favorite science-related thing that you've ever done?
Oh, that's a good and tough question. There's a lot of good science-related things in my life, but probably the most impressive thing was when I first got into an MRI scanner and I saw the picture of my own brain afterwards. So it definitely, it was a whole new definition to the word selfie. and yeah, it was very amazing as someone who was invested and interested in the brain and actually seeing my own brain, or my brain seeing its own brain. It was a very cool and very, very fun thing to do. It was also a study for my friend, so I was helping a friend out at the same time. So just the whole atmosphere was very cool. And I think that was the most memorable thing in terms of what kind of awoke me and kind of told me, like, all right, this is cool. I want to continue studying this stuff. Yeah.
Cool. Why were you in the MRI? What was that study about?
Yeah, so that study was about, I have to remember here. Oh yeah, it was about you had to memorize things. So it was a memory study. So you watched the video and then you were performing a memory task afterwards. So it was asking you, did you see this type of object, or did this actor say this type of thing? And yeah, they were looking at the brain functions related to that. And I think they had specific manipulations that I was probably not even aware of, as all good science experiments are doing.
Yeah. So what is a manipulation? I feel like we should.
Yeah, good point. That's a very important concept in science. So manipulation is when the researcher is actively doing something in the study to try to affect what you're doing, essentially. So in the case of my studies, I might place a bigger object as the second object before the first one you're grasping, and I want to see if you're going to grasp with a larger aperture for your hand, so the opening of your hand. So in this case, I'm manipulating what the second object is to see if it affects your first action. I could do this in a different way, where maybe I'll tell you to just do a perception task. So tell me the size of the object instead of grasping the object. So it's kind of a manipulation where the participants in the moment is probably not aware of what's actually happening. They probably just think it's a random sequence of things. But deep down, as a researcher, we're actually planning this, and we're trying to see if this will change the results of how you do something. In this specific case, how you reach out to grasp the first object.
Yeah. So in psych studies in general and in neuroscience studies, it's not really complicated to try to not trick people, but in a way trick people into giving you the information, because if they know what the trick is, it's going to change how their brains work.
Exactly.
So there's kind of a lot of tricking involved, right?
Yes, and you got to get very creative with it too. And sometimes there are some deception involved, where you don't want to reveal too much. But then afterwards, of course, the participants will get fully debriefed and they'll appreciate the beauty of what you just created. But yeah, you're totally right. It takes a lot of creativity, and that's where science is a lot of fun as well, where many students don't realize it. They think sometimes it's just a boring thing you do in school, but turns out you can get very creative and do some very fun projects by using the scientific method. So by using these various manipulations, you can come up with specific predictions, which leads you to better theories and whatnot. So yeah, definitely a key ingredient in your science experiment to have a manipulation that relates to whatever you're trying to figure out.
So you mentioned getting the MRI of your own brain as like a moment for you. Was that the moment when you knew you wanted to be a cognitive neuroscientist?
Yeah, so it's definitely a moment that enforced and kind of clarified that, yeah, this is definitely for me, and I like this stuff. But I kind of knew before that. I kind of started university not really knowing what to do, but once I started getting into psychology and I started to realize that the brain controls movement through the spinal cord, which sounds very, very straightforward, but when you think about it, there's a lot of complexity going on there. And I just fell in love with movement control, and I was always a big sports fan, and I always played a lot of sports, so I always had a passion for movement. Even thinking back when I was young, playing hockey, and I was a goalie, I could picture myself doing a mitt save out of nowhere, and thinking afterwards, I was not even programming this, it kind of just happened. So I was always curious, even at a young age, but then once I finally went to university and decided to pursue psychology and neuroscience, it became very clear that this was the path for me, and I had a lot of good ideas of how to pursue further ideas as a science discipline within the motor control and perception area of cognitive neuroscience. But yeah, that moment where I saw my own brain, I kind of realized this is the brain looking at itself. It was very cool.
A very meta moment.
Exactly.
Yeah. Do you have, and you may or may not actually have an answer for this, are there any things that we've learned from neuroscience or cognitive neuroscience that that have been applied to sports, or that the sports world has used?
Yeah, there's actually a lot of things. So when it comes to focus and attention, there's a lot of techniques that, like most of the sports teams will have a sports psychologist now, just in charge of all those things, because the mind is such an important factor for every sport. It doesn't matter which sport you're looking at. So yes, there's definitely a lot of application in terms of focus and making sure you're not distracted, because as we know in the type of things that I do, as soon as you start paying attention elsewhere, you start being distracted and errors will emerge. Whereas if you're focusing more on the task at hand, you'll perform better, essentially. In terms of like a putting example, if you picture the hole bigger, you might have a higher chance of getting it in. So you can kind of trick your mind and kind of behaving in a way that kind of supports what you want to achieve. By picturing it bigger, you might have a greater chance of putting it in. So those little type of mental tricks. But yeah, we're still kind of trying to figure out everything before we apply them directly. But yeah, one fun thing about perception and action is that because they rely on different parts of the brain, you can kind of use the other to trick the other. So whatever you're planning will trick what you're seeing, and what you want to see can trick what you want to plan. So yeah, so like illusion studies where you see a circle and you think it's way bigger than it actually is. If you go out and reach for it, you're going to scale it exactly the length that it actually is physically, not what it appears to be.
Oh.
So the motor system is kind of aware and doesn't fall for illusions, whereas the perception system does. So you can kind of gear that to your advantage when it comes to like a free throw, maybe picture that basket a little bit bigger, or in a putting situation or whatnot.
That's really interesting.
Yeah.
That like one part of the brain can kind of trick the other, but your motor system still knows what's going on. Like you're still going to, you still know the actual size of it, even if you see it as bigger than it actually is.
Exactly. Yeah.
That's really interesting.
Yes.
Do you have any advice for people who might be interested in this type of thing?
Yeah, so if you're interested in cognitive neuroscience or psychology or neuroscience in general, you're looking at the right space, because it's definitely expanding, and it won't disappear anytime soon. It's like we already discussed, it's relatively new science, and although we know a lot about the brain, we don't know a lot. So essentially there's still a lot to discover. Major discoveries taking place. We know a lot more than we knew 20 years ago, but we still don't know a whole lot about it. So many more details needs to be discovered in order to give a better outcome for people with brain injuries and whatnot. So yeah, definitely don't be discouraged to coming towards psychology and neuroscience, because we need you. We need more psychologists and neuroscientists out there. In terms of any other advice, just be curious and always question how behavior happens. So you might be, like I said, playing a sport and you realize you did a mistake, kind of trace back and kind of see where that mistake emerged and how you can correct it. And you might discover something about your brain in the process. Or you might be fascinated by a behavior that you can perform, maybe on the guitar, where you can do the solo no problem, but if you go to explain it to someone, you can't really explain it. So what's going on there? Why can the motor system do that thing, but when you're consciously trying to explain it, you're having a hard time to do it? What's going on there? So be curious about stuff like that. Question everything. Ask your teachers plenty of questions. And definitely be curious about how human behavior works. So that's another good thing about psychology and neuroscience, unlike other science, where you often need some fancy equipment to kind of know the mechanisms of things. In psychology and neuroscience, you see human behavior and you deal with human behavior on a daily basis, because I'm assuming if you're listening, you are a human. So yeah, definitely be curious, explore all types of things, and be open to all types of science and all types of disciplines in school. Psychology and neuroscience are probably the disciplines that combine the most out of all the other fields. So yeah, there's a lot of stuff to learn and to pursue. So yeah, I would highly encourage everyone listening out there to check out neuroscience and psychology, and maybe cognitive neuroscience specifically.
Yeah, I love that. And it's true that because you're studying humans, a lot of studies can be really, really simple, and you can even try to do your own studies at home.
Exactly.
Without all sorts of fancy equipment. Like you've talked about MRI machines and motion capture, and all those are some really cool, helpful tools. But lots of psych studies are also sometimes surveys and just having people come into a room and say what they see, or asking them questions, or playing them a noise or a video. So that's part of what I love about psych too. Is
exactly.
It can be really simple. You could, you can measure your dog's behavior and see, what happens when you suddenly start showing it a different toy every day that you give it its food or something. Like you can do really simple things. That's a very fun part of it. You can try to trick your friends.
Yeah, exactly. No, it's you can do experiments every day.
Yeah. Well, thank you so much for joining me, Kevin. Was there anything else that you wanted to mention?
I think we covered most of the important things here. If ever you're interested in psychology or neuroscience, specifically at Dal, don't hesitate to contact us. Like I already mentioned, I'm an instructor for the department, and I'm also the outreach coordinator. So if ever you want us to come to your school, or you want to come here and check out some things, definitely feel free to contact us, and we'll rearrange something.
Yeah, that's super fun. Super cool. And as always, a big, big thank you to everybody listening. Do you have a question that you'd like answered by an expert? Send us an email or a voice recording at whatdoscientistsdo@superstaff.ca. For more science fun, you can also follow us on social media at ScientistsDoPod on Twitter and Instagram. Thank you so much for listening, and I'll see you next episode. Bye for now. This podcast was made by Supernova at Dalhousie University, a network member of Actua. For more information on our summer camps, workshops, and more, check out supernova.dal.ca.